All right, so let's go on to group 2A, the alkaline earth metals, and describe some things about their chemistry that are of note. Again, metals, so they're metallic and bright and silvery. Again, like the group 1A elements, they're reducing agents, which means what? If you don't remember for sure, they lose electrons easily, which is why their ionization energies are somewhat lower. So they lose electrons easily compared to some other groups of the periodic table. That's what a reducing agent does. They're relatively soft, but they're harder than the group 1A elements. They're not quite as reactive as group 1A elements, but again, because they're somewhat reactive and fairly reactive in general, they're only going to occur in salts, in compounds with things like halogens. So a reaction with a halogen for a group 2A element. Well, what should we have here? So group 2A elements, being beryllium, magnesium, calcium, strontium, or barium, could react with any of the halogens. Remember again that the halogens are X, and that would be fluorine, chlorine, bromine, or iodine, which always occur in pairs, is diatomic elements. Got to remember those. We're going to run into them that way every time. And so the resulting products are always going to be group 2 metal halides. Again, these are similarly named, but metal halides, but they're a different kind with group 2 elements. We'll look at some examples with more details in a moment. All right, so reactions with oxygens will also occur, and oxygens reacting with, as a gas, reacting with the metal, which is a solid, is going to give you a metal oxide, and the oxides are all going to be similar. We're not going to look for crazy variations like we did with the alkali metals this time. And the interesting piece again is the reactivity order. For the group 2 elements, analogous to what we described for group 1 elements, the reactivity gets smaller as you go to the top of the column. The most reactive ones are going to be the ones at the bottom. Barium and strontium will be more reactive than magnesium or beryllium. Good patterns to know. These two also react with water, and when you put them into water, you get this nifty bubbling image that's shown on the left here. If you put them in water, what's happening? The metal ion is reacting with water again. In a similar fashion, they're making hydroxide ions and hydrogen gas, similar to what we saw with the group 1 elements. So for magnesium, calcium, strontium, or barium, you can get this to happen, but beryllium not so much. It's not terribly reactive. So these are far more reactive with elements at the bottom, namely barium, far less reactive with beryllium. Not enough to notice in that general sense. The group 2 elements then are making reactions the way they do because they are going to tend to lose 2 electrons. Where are they losing them? Well, these are all elements that have ns2 as the valence electron configuration. The shell number is always 2 or greater because there are no group 2 elements until you get to beryllium. And the ones they lose are outer shell electrons to become metal cations. We call them divalent, or doubly charged, if you will. When they react with when confronted with water, beryllium, as I mentioned, is not particularly notable in its reaction. But if you put in magnesium, and you can do it with water as a gas, that would provide more energy, more likely to react, then you can make the metal hydroxide, the magnesium hydroxide in water, plus hydrogen gas, which is explosive, of course. You have to be cautious in doing that kind of thing. If you were to take any of the other metals, like calcium, strontium, or barium, you could do them without having the water hot, and so they're less, the magnesium's less reactive, so you need to have heat to make this one go, to make it react with magnesium, but the other metals, calcium, strontium, or barium, will react without just water as a liquid to make the metal hydroxide with hydrogen gas. They're all going to look the same in the sense of having 2 hydroxides with a +2 cation from the group 2 element. Again, the reactivity is greatest at the bottom of the group. To conclude this short discussion, there are some photos of representative samples of each of these elements representing the notion that yes, they are hard and shiny. They mostly look like metals if you would have to give them a guess, but the one on the bottom right is radium. I haven't described that one yet because it's a radioactive element and not likely to be encountered in any of your examples. It would have some very unusual properties that you would not want to encounter in a direct way. Okay, I hope that helps you for the reactions of alkaline earth elements.